A fantastic weekend, and we're nice to your mothers on Sunday for Mother's Day. Today, we're going to continue with our new unit on organic chemistry. If you guys struggled with the worksheet from Friday, let me know. I could always spend a little bit more time on them or send you guys a video to help out. But today, we're going to move on to more naming of organic compounds. This one's a lot easier than Friday because you have a reference table to help you out. But today is all about these things called functional groups. And functional group is just a fancy term for an atom or group of atoms that's bonded inside a hydrocarbon chain. So remember, hydrocarbons are just compounds that contain hydrogen and carbon. So if we stick a different atom or group of atoms into a chain of carbons, we call that a functional group. So for instance, this chlorine molecule, let me get the pen out. This chlorine molecule is a functional group because it's attached to the hydrocarbon chain. In this case, it's a 3-carbon chain. And if you remember, a 3-carbon chain starts with the prefix prop. So we know that this is 3 carbons long. Somewhere in here, there's a chlorine, and that we call a functional group. And what's special is that each functional group has distinct properties. So something with a chlorine is going to behave very differently than something with, say, an oxygen, or that has, say, a nitrogen, a different element, right? It's different elements we already know behave differently. Same thing with different functional groups. And before we even get into the different types of functional groups, I want to go over table R, because table R is really your best friend in this part of the unit. It tells you all you need to know about organic functional groups. And if we look at the headings, which you guys know I love to do, you'll see class of compound. In reality, that just means it's the name of the functional group. So here, the name of this functional group that's in this row is halide. In this one, it's alcohol. Well, what's the second heading? Functional group. That actually tells you the atoms involved in the functional group. So if you have a halide or a halocarbon, you're going to have a functional group with either a fluorine, a chlorine, a bromine, or an iodine. If you have an alcohol, you're always going to have a carbon with an OH attached. The general formula is going to show you where the atoms are bonded in the chain. And if you look, X in this scenario can represent any one of these halides. So this X can be a fluorine, chlorine, bromine, or iodine. The R, then, if the X represents the thing that we're looking for, the R is going to represent the carbon atoms in the hydrocarbon chain. So it's like all of the carbons. So let's say that there are 3 carbons and then a chlorine, right? And there would be hydrogens all throughout here. Your chlorine is the X, and then if I can get, let me get a different color. This would be your R group in blue. These 3 carbons would be your R group. It's just all of the hydrocarbons that are in the chain. And then finally, let me get rid of this eraser. Ooh, this is obnoxious. Okay. Lastly, the example is nice and easy. It just gives you a condensed structural formula and a sample name. What I want you to pretty much pay attention to is the condensed formula and structural name, and then the general formula. Those are going to be your best friends because this is what's going to help you name the things. You don't have to memorize how to name a halide or an alcohol or any of the other compounds. It's right here in table R. So we can tell that this is a halocarbon because right here is a chlorine, and a chlorine uses the prefix chloro. So if we were to draw this out, we know that there's a chlorine attached. Remember, the 2 tells us the location of the chlorine. And I'll get to this in the next slide. But all of this tells us where that chlorine is, the fact that there is a chlorine, and how long the chain of carbons is. In this case, prop, again, means 3. So we're going to kind of add on to table R. I added a example structural formula. So whatever the example is, it's going to draw it out, and then it's going to give you like a little tip of what to look out for the functional group. So as I go through this, pay attention, fill in the table that's on your notes, and just really make sure you're comfortable with this column and this column, the general formula and the example. So again, let's say we had 2-chloropropane. If we were to draw it out, you would see a 3-carbon chain, 1, 2, 3, from the prop. Oh, I'm on eraser still, 1 second. So again, that prop tells us that there are 3 carbons. The chloro tells us that there's a chlorine somewhere in there, and the 2 tells us where it is. So if we number 1, 2, 3, right? That chlorine is on the 2nd carbon. So we say it's 2-chloropropane. The chloro tells us that there's a chlorine, the prop tells us the chain length, and the ANE ending tells us that there are no double or triple bonds because it's an alkane. So for halocarbons or halides, you just need to look out for a halogen combined to any carbon on the main chain. Very simple. If it's a chlorine, use chloro, fluorine, fluoro, bromine, bromo, and iodine, iodo. And you have to put the location of the chlorine, because if the chlorine, let's say, were on this carbon, it would be a different compound. That would be 1-chloropropane. An alcohol, as we can see, has an OH group. So here, when we have the condensed formula, CH3, CH2, CH2OH, we know that there's a 3-carbon chain with an OH at the end, which is going to look like that. So you can see the OH is at the end, prop again because there are 3 carbons, and the 1 tells us the location of that OH group. It's on the 1st carbon. Now, I know what a lot of you guys are thinking. Well, isn't that the 3rd carbon? But remember, we can number left to right, 1, 2, 3, or we can number, keep doing that again, or we can number right to left. So this will be in blue if we number from 1, 2, 3. And the number is the smallest number possible. So if we were to go from left to right with the blue, this would be 3-propanol, but we don't want that because we want to use the smallest number possible, which is from right to left. It's on that 1st carbon. So this is 1-propanol with an OL. That's how you name alcohols. Pay attention because in this column tells you how to name the things. So you put 1-propanol, you drop the ANE ending and add this OL. And again, you just want to make sure that there's an OH group bonded on the chain of carbons. Very simple. An ether is special because it has this oxygen atoms that combines 2 R groups. So if we look at this picture, we see that oxygen, and then we have 2 carbons on the right and a carbon on the left. This one I would say is the hardest to name because what you have to do is name one side of the ether and then the other side. So if we were to draw a line right where this oxygen is, the left side of that oxygen has 1 carbon, which we call a methyl group, right? Meth meaning 1, a methyl group is 1 carbon with the hydrogens. And the right side has 2 carbons, which relates to that ethyl group. So when we name this, we're naming the carbon chains on both sides. So this is methyl, ethyl, ether. If there were 2 carbons on each side, it would be diethyl ether. If there was, let's say, an ethyl and a propyl group, it would be ethyl propyl ester or propyl ethyl ether. Doesn't really matter. In this, you're looking for 2 alkyl groups, so 2 carbon groups joined by an oxygen atom between them. Right? And just be careful with the naming. You name both carbon groups and put the word ether at the end. Now, these next 2 are very similar. If we take a look, they both involved double bonds to an oxygen, but if you notice with an aldehyde, there is a hydrogen attached to that carbon that has the double bond. Here, it's not a hydrogen, it's some other carbon group. So for instance, you can see this carbon has that oxygen and a hydrogen bonded to it, whereas here, It's hard to see, but you can see this carbon that has the double bond to the oxygen is not bound to a hydrogen. It's bound to a new carbon group. So a aldehyde, the double bond is at the end of the carbon chain. A ketone, the oxygen is an inner carbon. And again, if we wanted to name this, we would look here. Well, prop tells us that there's 3 carbons, and anol tells us the ending of the aldehyde. An aldehyde will always end in NAL. So if it was ethanol, or sorry, ethanal, my bad, because ethanol is OL, ethanal, we would know that there would be a 2-carbon chain with an O double bonded to a carbon with the H. We don't need to put a number because it's at the end of the carbon chain. We know that if it's an aldehyde, it's at the end of a carbon chain. You do not need a number because it's always going to be on the end. A ketone, however, we do need the number because it's on an inner carbon. So where we get this number, again, is just similar to what we did up here with the alcohol. We numbered the different carbons from left to right and from right to left. We saw that the lower number is when we number from right to left. It's on that second carbon. And ketones end in this ONE. So this is 2, meaning the location of the double bond. Pentanone, because there are 5 carbons. Pent meaning 5. So just be careful with the difference between an aldehyde and a ketone. We have 4 more to go over. Organic acid is sort of similar to aldehyde and ketone, except instead of that carbon being bound to a hydrogen or a carbon, it's now bound to an OH group. So you have something that looks like this. 3 carbons. That last carbon has a double bond to an oxygen and then a bond to an OH. So you're looking for a COOH on the end of the chain. Again, since it's at the end of the chain, we do not need a number when naming this type of compound. Organic acids do not need a number because we know that it becomes at the end of the chain. Well, where are we getting this propanoic then? Well, the propanoic comes from the fact that there's 1, 2, 3 carbons. Prop meaning 3, and acids or organic acids are always going to end in noic acid. So you can have ethanoic acid, propanoic acid, butanoic acid. It's always going to have that same style of naming. An ester sort of looks like an ether, if you ask me, and it's sort of similar in naming it. So if we look at it, it has that double bond to an oxygen with that O group that is, or with an R group connected to another O group. So it's sort of like a mixture between a ketone, aldehyde ketone, and an ether. Pretty much what you're looking for is that COO group in the middle of the chain. And if you notice, we name it very similarly. We can draw like that line across or in between the oxygen. On the right-hand side, there's 1 carbon, which is where the methyl comes from. On the left-hand side, there are 1, 2, 3, 4 carbons, but we really don't count. Oh, I got the wrong picture. I'm sorry. There shouldn't be a carbon here. This should not be a carbon. There we go. So now there's 1, 2, 3 on the left, so it's propanoate. So it's methyl propanoate because there's a methyl group on one side, and then the side that's connected to the oxygen has 3 carbons, so it's propanoate. Next, we have our 2 nitrogen functional groups. One is nitrogen bound to 3 things, and one is the carbon double bonded to an oxygen bound to a nitrogen. So just so you can see what this looks like, one propanamine, funny or hard to say, is just 3 carbons bound to a nitrogen bound to 2 hydrogens. So there's an NH2 attached to any carbon of the main chain. Very simple. Here it gets a little bit more complicated because you have that C double bond O, NH2 on the end of the chain. So if you see a double bond, it's an amide. If you don't see the double bond, it's an amine. And they're very similar to name. One ends in amine, and one ends in amide. The amide is going to end in amide. The amine is going to end in amine. Again, since the amide is at the end of a chain, you do not need to put a number at the beginning of the name. So this does not need a 1-propanamide because you know it's at the end of the chain. This one, however, since that nitrogen could be attached to any one of these carbons, you need the number in the front. So you need to say 1-propanamine. Propanamine. So again, if it's at the end of the chain, like an amide, like an organic acid, like if I go back, a ketone, like an aldehyde, my bad, you do not need the number. But if it comes in between, you need the number. So you need the number in an alcohol, a ketone, you need it in an ester, and you need it in an amine. So these are a little complicated, but again, look at these 3 columns to help you. The example gives you how to name it, and if you need a number, the general formula will help you determine what type of compound it is. All right, so try out this worksheet. I know that this is hard, so I'm giving you guys 2 days to do it. You're gonna have to draw some, and then I'm gonna give you some compounds that you have to name. So it's a little bit of both. So you have to recognize using the structural formula what type of compound it is, and then using the condensed formula, you have to name it. So tricky, but try your best, okay?